Good evening, everyone. As Levi mentioned, my name is Cameron Presley, and if you're in the right room, right Twitch channel, right Discord group, you're here to learn about functional programming, and we're going to do it through first principles, which means I'm going to assume that you know pretty much nothing except functional is a word and programming is hopefully something you know how to do. Before we get into it, let me tell you a little bit about myself. I am a software engineer based out of Charlotte, North Carolina, and a Microsoft MVP in developer technologies. All that means is that I love talking to people about technology. When I started out, I didn't know anything and I could do even less. And it was the community that really brought me up, right? Taught me what I knew, really helped refine my skills. So I do that as well to try to give back. And as such, I've been recognized as an MVP. So that's all it means. I love talking about technology. I'm also a builder, right? I love building things, not just software, but also carpentry. Here's a picture of one of my first projects, and it still works today. Is it the best thing I ever made? No, but I feel like there's value in showing the progress that you make over time. So, and you'll see a little bit about that in the coding we do this evening. And last but not least, I am a professional software consultant for a company called Lean Techniques based out of Des Moines, Iowa. Long story short, we make companies awesome. So that could be through digital transformation. Maybe you've got a project that's just kind of stalled out and you need some extra technical horsepower, or maybe the way you're approaching problems just isn't great and you need an outside perspective to help you out. If any of this sounds familiar and you want to learn a little bit more, hit me up after this session. Love to chat with you about that. And then the last bit of housekeeping. Look, Ma, no need to take notes. Everything you need for this evening is already live. So if you trust me, blindly scan the QR code that you see on the screen, and that'll take you to the slide deck, code, resources, everything. If you don't trust me, or maybe you're a security engineer, go ahead and go to that URL instead, blog.softwarementor.com/presentations. Scroll on down to the name of this talk, which is FP through construction, and you'll be able to see everything there. But enough about that. Let's get into it. Did you all know that you're actually at a summer camp? No? Well, you are. We are at a summer camp and we are volunteering to help out the robotics club to build out a rover. Thankfully, though, we're not having to do the hardware engineering, mostly because I'm partially colorblind, so you don't want me near a soldering gun and wires that where the colors mean something, because that's going to go problematic for you. So instead, we're going to focus on the software side. We are going to develop an API that knows how to take some commands that are sent from Earth and translate to instructions that could be understood by this rover, right? So at a very high level, we're building an emulator. All right, but now let's talk about what some of our restrictions are. Our first restriction is we are going to design code in such a way that engineers can't ship bugs because the code won't compile. I don't know about you, but how many times have you worked in a code base that allowed you to do something that either broke business rules or it would put the system in a very unusual state, right? I'll raise my hand. I've been in tons of code bases like that, right? So you're going to see a couple of ways tonight that we can actually design our code in such a way that that can't happen, because if it did, the code wouldn't compile, which means you can't ship it. And if you think this is kind of a crazy idea, well, Jeff Atwood from Coding Horror, you might also know him from some little thing called Stack Overflow, I believe. He actually wrote in an article called Falling to the Pit of Success that a well-designed system makes it easy to do the right things and annoying, but not impossible to do the wrong things. And that's what we're going to strive for this evening. So enough with that. Let's talk about the problem at hand. So we've got a list of requirements. So we've got this rover, and it has some starting point, an X and Y coordinate. So think like a two-dimensional plane or a graph from like your algebra days. And the rover is going to be facing some direction, north, south, east, or west. It's not going to face like northeast or southwest. It's going to face one of those four cardinal directions. And that X and Y coordinate I mentioned earlier, those are going to be whole numbers. We don't have to worry about half a unit or 3/4 of a unit, right? We're going to make this real basic. And the rover has four commands that needs to be able to operate: move forward and backward, and then turning left and right. And we'll explore those requirements a little deeper as we go through the presentation. But first things first is that we've actually got to design the models, right? Our domain. We got to figure that out. So for those of you who come from an object-oriented background, you may be familiar with a technique called like noun identification, right? This idea that The nouns are your classes and the verbs are the methods. Well, in functional programming, we can kind of leverage that same idea where your nouns are going to be your types and your verbs are going to be functions. And you'll see that as we break through. So let's go ahead and do that domain modeling looking at the nouns. So as I kind of alluded, we're going to look at the nouns, and there's really three. We've got rover, right? Because if we don't have a rover, that kind of defeats the whole purpose, right? We have a direction, right? The rover's got to be facing one of them. And then it has a command. So, and you'll see that there's an arrow between rover and direction because rover has a direction, right? So you've got some type of relationship there, whereas command kind of stands by itself. The cool thing with domain modeling, especially this way, is that if you draw this dependency graph, you can actually figure out the way to implement your types by flipping the arrows around. So if we're going to build out our model, we need to implement direction. Once we implement direction, then we can implement rover, and then we can implement command at any time. So let's take a look at how we can do this using TypeScript. So even though we're going to be using TypeScript for this evening's session, these concepts actually work in most languages. It just may be done slightly differently. So you're going to hear me use certain terms like sum types or tagged unions, things like that. Don't get too hung up on that terminology. Just realize that it's a technique of modeling this and that your programming language of choice may model it slightly different. But for direction, we know it can only be one of four possible values, right? Anytime that you find yourself modeling a type where it can only be one of a finite set of values, you're going to want to use something called a union type. Now, and an example of union type in TypeScript looks like the following, right? So we have a type called direction, and it's got one of four string values: north, south, east, west. It can't be any other value. Can't be it. Now, you may look at this and think, well, Cameron, this is kind of like an enum. It is, but it's actually a lot better, right? If you think about enums are really numbers disguised around as constants. Really, that's what an enum is under a hood. And there's nothing to stop you from typecasting a number to force it to be an enum type. Those of you from a Java or C# background know exactly what I'm talking about here. This is a lot different. I can't really force a conversion here. I would have to try really, really hard to make that happen. So much so, in fact, that if I were to try to write some code and say, hey, I'm going to create a direction called kumquats and assign it to some variable called invalid direction that has the type of direction, the compiler will smack me on the wrist and go, hey, you can't do that, buddy, right? Because it knows, hey, that string kumquats, it wasn't one of those four possibilities. So right off the bat, I've already eliminated a whole slew of bugs from my system because I decided not to model direction as just a string. I said it had to be one of only four possible strings. So that's a whole bunch of error handling we don't have to write. That's cool. So direction's done. Let's take a look at command. So command can be one of five possible values, right? You got move forward, move backward, turn left, turn right, and then quit. Because if the rover doesn't quit, then it's going to, I won't say fall off the edge of the cliff, right? Maybe in Mars it can do that, but that's a different problem altogether. We can use the same technique here as a union type though, right? So we'll say type command, and it's one of these five strings. And once again, by defining our types this way and saying it can only be one of these five values, we are preventing a whole slew of bugs from ever being introduced to our system because the code literally won't compile. To prove the point, let's say I try to create a command and assign it the string value of platypus. You'll get this delightful error from TypeScript saying, no, you can't do that. It's not assignable. Quit it. And that's awesome, because if we're going to work in a compiled language, I'd rather the compiler actually help me out and not nag. And this is a good help. So at this point, we've talked about situations where if you have a type where it can be one of a possible set of values, you can use unions. But rover is a little bit different because it's not one of a finite set of values. It's actually a combination. You're combining things together, right? If we go back to our requirements, it's the fact that we have an X value, which will be a number of some sort, Y, that's a number, and a direction. You have to have all three of those things. Otherwise, you don't have a rover. When you find yourself in this situation, you're going to want to use something, either an object or a record. It depends on the language. If you're working in .NET, I highly recommend using the record type because you get a lot of cool stuff for free, like immutability pretty much comes out of the box. You get force constructors, all that fun such. But if you don't have records or you're working language without them, objects will work in a pinch. In TypeScript, we're going to use, as you can imagine, a type here, and we're going to kind of use some record syntax. So we say, if you're a rover, you have to have 3 properties: an X that's a number, Y that's a number, and direction that's of type direction. Once we've defined rover, it has to have these 3 things, nothing more, nothing less. So much so, in fact, that if I try to create a rover variable and I gave it the X of 0, Y of 0, direction north, everything's fine. But the minute I try to give it a wheels property, well, the wheels fall off, right? Because we get this error from the compiler. It says, hey, wait a minute. The object literal can only specify these known properties, and we have no clue what wheels is because it doesn't exist in rover. That's awesome. Once again, it's letting us throw out a whole bunch of error or a whole bunch of issues we could have walked ourselves into without necessarily have to write all this error handling code and whatnot. So we've got rover, we've got direction, we've got command, but there's a small bug with rover, the way we've defined it so far. And I'll show you what I mean. Let's say that we have this function called log rover. You pass in a rover, it's a void function. That means we're not expecting it to return anything. And it does a console log and it says, hey, rover is going to be at XY coordinate facing this direction. And then we increment the X value. Now, this should look a little bit odd to you because we said, hey, wait a minute. This is a void function and it's also log rover. So I would expect it to log something. Otherwise, why would we call it log rover? But this is the part that's a bit more surprising. This is changing something about the rover. I wouldn't expect the log rover function to do that, right? The name doesn't imply that. The return type doesn't imply that. So why is it doing that? That's not cool, right? Because I may call log rover and not realize that's actually updating something about it. And now my code's not going to work the way I think it is, right? I don't know about you, but I've definitely worked in code bases where we had this kind of shared state that was being changed in lots of places, and it's not fun to troubleshoot. So how can we fix this? Well, the problem was that when we defined a rover, we said it had an X, Y, and direction, but we didn't set any restrictions on those properties. So instead, we're going to add this read-only modifier. Now, read-only definitely exists in C# and .NET. I imagine it exists in other languages too, just maybe called something slightly different. But once we put this read-only modifier on these properties, something interesting happens. Remember that function we just had about log rover and how the compiler was totally happy and there was no problems with it? We had to know something was wrong. The compiler doesn't like it anymore because it says, hey, wait a minute, you're assigning a new value to X because you're incrementing it, and X is read-only. You can't do that. Ooh, okay. So I can't compile anymore. So now if I wanted to fix this, right, I want to make my code compile again, I've got to update this function definition, this function signature. So here's what I'd have to do. I have to now say that it returns back a rover, because if it doesn't, then I can't make any changes. And now to return back that rover, I have to create a copy. So in TypeScript and JavaScript, you have this spread operator, those triple dots there. Essentially what that's saying is, hey, take everything that R was, all the properties, except whatever X is, I want you to use what it was and add 1 to it. Now, I don't know about you, but this code clearly looks wrong now, right? If I didn't look at the implementation and I just blindly called log rover and I saw that it was returning a rover, my eyebrow would raise up a little bit, like, huh, that's weird. Why is it doing that? And there's actually a kind of a principle behind it. Joel Spolsky on Joel's, Joel on Software, he wrote a blog post called Making Wrong Code Look Wrong. And he talked about this idea of you deliberately architect your code in such a way that your notes for uncleanliness makes your code more likely to be correct. This is the real art. Robust code by literally inventing conventions that make errors stand out on the screen. And you've kind of seen a version of this, right? If you're keeping up so far and you're kind of understanding this, congratulations, you've actually already understood one of the first principles of functional programming, even if you didn't realize it, immutability. So when we say something is immutable, we're saying that it's an object, record, take your pick here. Its state can't change. Once you have created it, it can't be modified, right? It can't be updated. It is what it is. And this doesn't sound super powerful, But you'll see that without immutability, a lot of the other principles we talk about doesn't work. They can't work. And the reason why I love immutability so much is that it's hard to keep track when state is changing. Remember I mentioned earlier working in systems that had global state, and you had to kind of figure out like, okay, well, this value is no longer what I thought it was. Did it get changed here? Did it get changed there? Did it get changed over there? You don't know, right? You have to kind of take pencil and paper and a debugger and figure out who broke it. With immutability, you kind of know where it's being changed at because either it isn't, or as you'll see later on, it's only being changed in very small places. And at that point, tracking it down is trivial. So here are the requirements we talked about before. That first one, starting point X and Y in direction, done, right? The way we've modeled our domain totally solved that problem. So let's take a look about implementing forward and backward. So when we take a look at the requirements, it's really based on the direction that the rover is facing. So if the rover is facing north, its Y value is going to go up by 1. Kind of makes sense, right? Remember that number line, like two-dimensional grid I was mentioning earlier? So, right, you've got your X and Y axis. So Y is going up. If you're facing north and you're told to move forward, you'll go up 1 on the Y. If you're facing south, you're going to go down by 1 on the Y axis. East, X is going to go up by 1. West, X is going to go down by 1. So that's the 4 directions we got to care about. That's the requirements. But before we write code, I want to challenge you a little bit and think about this problem slightly different. We know that if this rover is going to move, i.e. its state is going to change, we have to create a new rover to represent this. So what I like to do is I like to create these mappings. So we're going to have a mapping. The first one is here is all rovers. The second group, if you will, is here's all rovers. And we're going to say, here's that first set. We're going to break up all possible rovers to be in one of 4 groups. All the ones facing north, all the ones facing south, east, and west. And then on the right, we're going to say, okay, well, we're going to take those rovers and change their Y or X value appropriately. And so now I'm going to start drawing arrows from the left to the right. So if you're facing north, the Y is going to go up by 1, south Y down by 1, so on and so forth. Now here's the question. Is everything on the left mapped to a single thing on the right? If it is, congratulations, you now know what a function is. That's what a function is. It's a mapping, right? If we look at the mathematical definition, we see that a function is a mapping between 2 sets such that every element in the first set maps to a single element in the second set. You may be looking at me going like, hey, Cameron, I'm not a mathematician. I don't quite remember sets. It's been a while since I've done math. Okay. No worries. Let's change this definition just a little bit. It's not quite technically correct, but it's close enough for you to get an intuitive understanding. Let's say a function is a mapping between 2 types, such that every value of the first type maps to a single value of the second type. With this definition in mind, now let's take a look at some mappings that aren't functions. Let's say that we've got one where we want to figure out how many days are in a month. So we've got our first type, which is all possible months. And then we've got our second type, which is the possible number of days. So we've got all of our months, January through December. Pardon, don't worry about the weird ordering. You'll see why in a second. And then we've got the number of days, and those are the 4 possibilities, right? There are no months with 32 days. There are no months with 27 days. It's either 28 through 31. Let's start drawing our arrows, though. January goes to 31. Cool, no problem. March goes to 31. Cool, no problem, right? Because they're both going to a single thing on the right. Doesn't matter if it's the same value, as long as it's only going to 1. April's the same way, it's going to 30, so on and so forth. But February is where the wheels fall off, right? This is where we run into problems because sometimes it has 29, sometimes it has 28. I don't know about you, but I don't like code that works on sometimes. I like it to be consistent, right? That way, if there's something wrong, I can easily figure it out. I can write tests against it, everything. Code that sometimes works and sometimes doesn't is a real pain in the butt. So for February to be mapped to 29 and 28, there's not enough information here. There actually has to be a second parameter that's floating around. The year. So for this to have actually been a function, we would have to change the input to not only be the name of the month, but also what year it is, because then we could figure out if it's a leap year or not, and then 29, 28. But as it currently stands, this is not a valid function. This will not work. Let's take a look at this one. Sorry, one of my slides has got messed up here, but so let's say that we were mapping from month numbers to names. One goes January, two goes February, so on and so forth. But 13, right? What's 13 get mapped to? Well, it can't get mapped to a month. There's no month name of 13. So this is what throws an argument exception, right? That's not cool, right? Because that's not a month. So you've seen yet another example where we could map everything on the left to something on the right. So now you've seen like the both scenarios. So going back to our move forward mapping, right? It's a function. We can implement a function. So let's do that. Here's what we've got. We've got a move forward function that takes in a rover called R. It's going to return a new rover. And we're going to do a switch statement on direction. TypeScript's really cool because it does exhaustive pattern matching. So because direction can only have been one of 4 possible values, I only have to write the 4 cases here. I don't have to write a default. And then kind of as you saw earlier in the logging example, I'm going to use that spread operator to take whatever rover was before and then change the Y or X value appropriately. And that's it, right? If you've got a little bit of an automated testing background, unit testing, for example, take a look at this function and think about how hard would this be to unit test? Not too bad, right? You saw how easy it was to spin up a rover, right? Spin up the direction and X and Y and pass it in and just make sure. It's not too bad. You'll actually find that most functions are pretty trivial to unit test because of this. And the reason why functions are so cool is that they're consistent, right? And the reason why that's important is because I hate debugging inconsistent behavior. That's a pain in the butt. I also don't like using systems that are typed like a C# or an F# or a Haskell or TypeScript or any of the other ones, right? If the types can lie to me. You saw earlier that we could write a function that says it returns a value all the time, but sometimes it throws an exception. Well, unless the compiler is going to help you out with that, you kind of just have to know, and that's not great. So we've implemented move forward. As you might imagine, moving backwards is going to be very similar, so we're going to skip over that. So let's take a look at turning left and right. So when we're turning left, it's once again based on the direction. So if we're facing north, we're going to rotate to the left 90 degrees and now be facing west. And if we were facing south, we'll face east. East goes north, west goes to south, right? This is a really cool rover. It's 0 degree turning, which means it doesn't actually have to like move its coordinates. So we're going to use that same mapping trick from before, right? So here's the set of all rovers going to the set of all rovers. I've broken up the first set into rovers facing one of those 4 directions. I've broken up the rover on the right to be same 4 directions, but ordered slightly different. And we're just going to draw our arrows over to it. Same question. Is everything on the left mapped to a single thing on the right? If it is, we got a function. So writing the code for this is actually not too bad. Switch statement yet again on direction, and we're just going to update direction as need be. And at this point, things are going to get a little bit more interesting because as you might imagine, turn right is going to be very similar. So the problem is now we've got all these disparate functions. We've got to glue them together. And a common term you're going to hear in functional programming is something known as a pipeline. And you can kind of think of a pipeline as literally just a series of steps that need to happen. So let's talk about the pipeline we need to build to make the Mars rover exercise work. First step, gotta get input, right? Users got to give us this command. We're going to assume command line here. So, and whatever you want that to be, we'll talk about that in a second. But once we get the input, we've got to convert that to one of the commands, right? Remember we defined those commands earlier in the talk? We got to know, did they give us the move forward command, move backward? What command did they send us? Once we have that command, we can then map it to one of those actions that we just wrote, right? The move forward function, the move backward function, turn left, turn right. And once we have that action, we can then call it with the rover that we have, right? 0, 0 facing north, we'll invoke that. And then this is the trick. We're going to throw away our old reference and just keep the new one. So this is kind of the pipeline that we've got to build. So let's start with that first step. User enters input. This could be console readline. This could be whatever TypeScript library you'd like to use. It could be from a file. It doesn't really matter. The big thing here is that it's some function that returns back a string. That's all it's got to be. So we'll implement that pretty quickly, right? Console readline, that's good enough. Let's talk about this next one, mapping to a command. So you might see where this is going, right? We're going to do our mapping again. So I've got a set of all strings, and I've got a set of all of our commands. So here's some strings, here's our commands, and these will map straight forward, right? F's go to move forward, B's go to move backwards, L's go to turn lefts, R's go to turn rights, so on and so forth. But remember what our first set is. It's the type of all possible strings, which means somebody can enter a string called platypus, right? It could enter a string called cheese. It could enter a brick. It could enter anything. It'd just be a bunch of question marks. What does that map to, right? It's not quit. It's not any of the other commands. It's got to map to something. What is it going to map to? This is a common problem that you will run into on not only functional programming, but even day-to-day coding, right? So input can be any string, but not all strings are valid commands. So when you find yourself in this situation, you got two choices. The first choice, and this is the one I try to stick with most often, is let's restrict our input to only be valid values. So do you remember when we were doing the mapping month to the number of days, and we said that first set was all possible month names? That's an example of restricting the input, right? We said, hey, you can't give us a string of cheese, or you can't give us a string of car because that's not a valid month name. In this case, though, we can't use this approach because we're getting the input from the user. So unless we're doing some type of mind control or some type of thing on their keyboard or file to prevent them from doing that, we have to be able to accept all strings, all inputs. And if that's going to happen, we take approach number 2, which means we've got to expand our possible outputs. Long story short, the way we've got commands defined isn't sufficient. We're going to have to add something else to it. Now, in some languages, you would use null. Maybe you would add maybe a maybe type or something like that. But in this case, we're going to make it real simple. We're going to update our command to have a new option called unknown. And with our command updated for unknown, we can now update our mapping to say that not only is platypus going to go to unknown, but in fact, all strings, if it's not F, B, L, R, or Q, are going to get mapped to unknown. Writing this in TypeScript, another switch statement, no shocker there. In this case, though, we have to have a default because since our input is string, it could be literally anything. So that's our unknown. Cool. Once we have this function in place, done, right? That requirement completed. So we've got a command. Now we've got to map a command to an action. So I said the keyword mapping. Let's see what that's going to look like. Got all of our commands. We've got our actions, which if you remember, they were functions that said, given a rover, I will return a rover. So here's all of our possible commands. Here's all of our possible functions that we've written. And we can map almost all of them. But oof, right? We've got quit and unknown. They've got to do something, right? We can't have a function that returns back an argument exception because quit and unknown are valid commands. So we need a function if we're told to quit or if we're told something we don't know what to do. So we need a function that says given a rover, return a rover. So let's write a function that does nothing. You may be thinking, Cameron, a function that does nothing. Yeah, let me show you what that looks like. It literally returns the input. No matter what you give me, I'm going to return it back. For those of you with a little bit of a functional background, you might know this as the identity function. I just gave it a different name, but it's the same concept. But now that we have this do nothing function, we can actually write the code for our mapper. So we can do a switch on that input. And as I mentioned before, right, because input can only be one of those 6 possible commands, we don't have to have a default case. Here's how we handle it, right? Forward goes forward, backward to backward, so on and so forth. At this point, We have a way of getting input from the user. We can map that string to a command. We can map that command to an action. We now need to actually call that action with the rover and get an updated new state. So it's a little bit hard to take both these steps separately. So I'm just going to show you the working solution here. So if you kind of pretend that all the other code we've written is in another file, here's what the main file would look like. We set up a rover. Notice I'm using the let keyword. In TypeScript, let means I can reassign this value. Right? I can reassign the reference, I should say. And then notice we set up a command being unknown because right now you haven't given us anything, so it's unknown. While our command's not quit, we're going to prompt the user for the string, and we're going to get that string into input. We then say, cool, command's going to be whatever that string is converted to a command. We're going to get the action from our mapper from before. It says, hey, given this command, here's the function we need to call. And then it's really that last line, rover equals action rover. That's the update, right? We're throwing away whatever the old value is and getting this new value. This is an extremely common pattern in programming. You can think of this like an update loop or a game loop. It's really what this is. Not too bad, right? Let's take a look at something slightly different, though. Instead of getting the commands from the user, what if you knew them all ahead of time? Let's look at what that implementation would look like. So we still have that initial rover, and now our input is going to be a string of L's, F's, RB's, F's, L's, and Q's. And then what we're going to do is on that final rover is this bit of logic, right? We're going to take that string, split it up into each of the individual characters. Then we're going to convert each one to a command, convert each of those commands to an action, and then we're going to reduce down, right? So essentially the same thing we did in the loop before. But the thing I want to call your attention to is, hey, we're running map twice, convert string to command and convert command to action. Do we necessarily have to do that? No. Let's take a look at those two map commands a little bit closer. So here's what's happening under the hood. We're taking all possible strings, mapping them to commands, and then eventually we're going to map those commands to rover. Instead of calling these two functions like that, we could, in fact, create a brand new function that composes all that functionality. So let's write an extension method. I say an extension method. Let's write a function that helps us compose. So here's one in TypeScript. Now, you may be looking at this going, oh my goodness, that's a whole bunch of letters and brackets, and I can't read that. Cameron, what are you doing to me? Don't worry about the generics on that first line. Really what you care about is the return statement, right? All that says is, hey, if you give me an input, I'm going to call the first function with that as the input, and then take wherever that first function's output is and pass it in as the input for the second function. So we're literally composing them together. I hate to use the word compose in its definition, but that's kind of what we're doing here, right? We're nesting them inside. Once we have this compose function, though, let's take a look and see how this would work. Same code from before, but here's where we can write a brand new function called string to action that composes convert string to convert command to action. And once we have that, we can then use it here. That's pretty cool, right? We've always talked about in development that we can build small programs and then compose them together to build big programs, but half the time that's not quite true. If you're working in functional programming, though, it is true because of how all of this works. For you to have composition, you have to have functions, right? You saw in our mapping from before, and I'll go back a little bit, if any one of these arrows failed, or if any one of these mappings wasn't a function, you can't compose them because the composition would break. So if you have composition, that means you have to have functions. And for you to have functions, you need to make sure that the data that you've passed in doesn't change on you all of a sudden or unexpectedly, which means your data has to be immutable. All of these concepts build up. If you don't have immutability, it's really hard to write functions. If you don't have functions, it's really hard to do like pure composition that works correctly. So let's wrap up. Immutability removes the ability for random access to internal state and to mutate it. And by removing this ability, it actually reduces the complexity that we've got to deal with. Functions Man, if you haven't gotten tired of me saying mappings yet, here we go. They're mappings from one type to another, such that everything on the left is mapped to a single thing on the right. And then composition is literally combining those smaller functions into larger functions. Thank you all so much for letting me hang out with you this evening. If you have questions, right, that you don't feel comfortable asking on the live stream or in the Discord or what have you, feel free to drop me a line at cameron@softwarementor.com. If you didn't catch this QR code from earlier, here's QR codes here. Otherwise, thank you all so very much. I appreciate it.
Fantastic. This thing on? Okay. All right. Can I get a volunteer to run a mic around for questions? You got questions? Tiffany's got you. All right, questions. And we got a weird mic situation, so Cameron can only hear me through the laptop here, so I'm going to have to repeat your question to him to make sure he hears it.
Man, that means I got to listen to Levi more.
Yeah.
Dang it.
There we go. We got one.
Okay, I was about to say, like, I know I'm good at what I do, but if no one has any questions, either I went too fast, I did not make enough sense, or I'm in the wrong line of work. Right, one of the three. Right, so cool. What question do we have, Levi?
I need to turn it on. All right, just a
that
second.
that will help. Yes.
What number is that? I might not have tested that one earlier. Oh, it was off.
Excellent. I love debugging in production.
Yeah,
it's my favorite.
Absolutely. Where else would you debug?
It's where all the bugs
ahead of
come
time.
out.
No.
So I've been trying to figure out how to word this, but so I like the idea of functional programming. How do you handle it when parts of your codes can't be functional? So
Okay.
For example, this would be a good one. So if you have a GPS on your rover where it's tightly coupled to X and Y, and you need to do something when that GPS gets lost, how do you have part of your code be functional and part of it not be functional?
It was a little long, and I think I lost it because I'm kind of tired. I was up late coding things. You want to just come up here and repeat the question? Sorry about that.
It's all good. I promise I'm not mean. I don't bite, especially this far away. I mean, y'all are very safe.
Okay, there we go.
All right, can you hear me?
I can absolutely hear you, sir.
Okay. So I love the idea of functional programming. My question is how do you implement that when you have portions of your code that can't be functional? So for example, if your rover is connected to a GPS system, so obviously state is coupled to something externally, which you may not be able to control.
Yeah. So what you end up doing is you end up putting boundaries in. You will usually hear a phrase called hexagonal architecture or ports and adapters. But what I do is I have the thing that gives me, so let's take your X and Y from the GPS, right? I'll get that from an impure way, which isn't too terribly different from that prompt user function, right? That's coming from the user. That's impure, right? It could be, right? It could give me whatever, but I'm dependent upon it, right? So I know that can't control, but I can control everything else. So it's not terribly uncommon for you to have like something stateful at the beginning, something stateful at the end, and then that pipeline in between is what's pure functional. Now, if you're using a language like Haskell or Scala, Clojure, any of those, they do have some ways of handling that state, but that's a little bit past the concepts of this session. Does that help?
Getting some thumbs up nods.
Okay, great.
Any other questions? Kayla, you want to just come up?
Yeah. So my question is just kind of, I'm thinking of what are like the strengths of functional programming versus object-oriented programming, and how would you recommend that programmers implement functional programming, if that makes sense? So what would be some good use cases for that?
Yeah. So functional programming is starting to become a lot more mainstream. If you don't mind me asking, what languages do you work with today?
TypeScript, TypeScript, Angular, PHP, some React. That kind of thing.
Perfect. Gotcha. So React, right, with their functional components, right, you already have this idea of dumb components that say, hey, just render this data. And then you've got smart components that kind of compose all of that. You can kind of think that as a functional thing. In fact, if you're using React, that means you probably have dealt with Redux at some point. That actually got its inspiration from that game loop that I just showed you. That actually came from a language called Elm, and it followed the Elm architecture, where you have this model view update pattern. If you just want to get started, though, the one I usually recommend people is stop writing loops, start using map filter reduce. The minute you start thinking about code that way, you've already started taking your first steps. That is a great intro. And those are concepts that are in most languages. Like everything I showed you tonight, you can about do it in any language. Because I don't know if I didn't mention this, but I will now. That compose function was interesting because it's a function that took in functions as parameters. In TypeScript and JavaScript, that works out of the box. That's worked since day one. Languages like C#, it took a while for that to get baked in. And you can do function passing like that, even in languages that most people wouldn't consider functional, like C and C++. You just do them by passing in pointers. Your second question is, how do I get started? Oh boy. So I actually have a whole separate talk on that topic. But for me is I wanted to pick up a language that was more functional by default and not like I could opt into it. So for example, in TypeScript, and I think Angular was mentioned, TypeScript and Angular, you're going to be following more OO patterns. That's kind of what Angular, older versions of Angular especially, follow more of objects and all that. React tends to favor more functions. But when I was learning, I actually picked up F#. I was a .NET dev, so picking up F# made a lot of sense, and it really helped me out a ton. Depending on what you're interested in, like, hey, I like doing functional stuff on the front end, though, you might want to look at a language like PureScript or Sanctuary. Both of those may make some sense there. If you're more of a back-end dev, then I like F# a lot. I really enjoy Haskell, but that has a little bit of a steeper learning curve. But those are some recommendations. If you want more info, like hit me up after this and we could talk more.
Another question here.
Hooray.
Yes, indeed. Given your point earlier in that subsection, sorry if I'm not close enough, you mentioned that this is something that can be applied to all programming languages. What should magnetize us to the concept like, yes, I must use Haskell for this purpose and not some other more dynamic language? It seems like good practice you could use in virtually any language under the sun, although having something like compose is certainly nice.
So I want to make sure I understand your question. Is your question of why shouldn't I use Haskell for everything? Or is it...
It's more the inverse of that. Why should I use Haskell and not just apply these lessons elsewhere, given that making sure things are concise and functional is, well, functional?
Oh, no, I am absolutely an advocate for using the concepts. What I find, though, is, and I'll spoil it, when I was learning F#, F# plays with C#, which means it deals with objects. So my first couple times writing F#, I actually wrote object-oriented F#. I needed a stronger, I didn't need the crutch, right? I needed a language that wouldn't allow me to write OO at all. So I couldn't fall into any of those practices. It forced me to have to think about the problem differently. But what I found is, and this is kind of weird, so when I learned F#, it made my C# skills better. When I learned Haskell, it made my F# better, which then in turn made my C# a little bit better. But I will warn you, if you start learning certain things, like in Haskell, you'll want to put that in C# and realize that you can't. Or you would write so much boilerplate code that the rest of your team can't support, like they wouldn't know how to support it. So what I actually do in my day job is when I'm writing in like C# or TypeScript or any of these other languages, I do use functional concepts. I do use record types where it makes sense. I do use pure functions that don't have to call out to third-party services and do compose them. And where I can't, that's cool. I use objects. I default back to where the language is good at. And that's okay for me.
Sweet. We got another question.
For languages that support both OOP and functional programming, do you have a good go-to argument for why to adopt functional over OOP? Maybe like sell it to your boss or something.
Ooh, so selling it to my boss is the wrong conversation. The reason why I say that, because if you're working as a team, your first priority, right, is to solve problems and hopefully not ship bugs, right? Like that's why you're there for. So I don't necessarily go into a work and say like, hey, this is a functional programming shop now, and it's my way or the highway. I just write the code in the way I'd like, right, in a functional style. But I'm also going to take consideration of the team I'm working with. So for example, if I am the only one who's got more of a functional background, I'm not going to start dropping maybes and monads and all this other category theory stuff. It's literally what I mentioned earlier. I'm just going to start with map filter reduce. And then people are going to notice like, hey, that code was really easy to read, or hey, that was kind of clean. And I like, yeah, or like, hey, that was really easy unit test. Yep. And then so I'm not selling you on functional languages, I'm just selling you on our approach. And it's up to you to use that tool appropriately, whether it makes sense in your use case or not. Does that help?
I'm getting a thumbs up.
Okay. There is a question. Sorry, really quick. There's a question in the Discord, and I'm going to say it out loud, and then
Go for it.
I'm going to flex a little bit. So Ryan asks, "Hey Cameron, can you explain this phrase? A monad is a monoid in the category of endofunctors." So for those of you who may be new to the functional idea, this is a common meme question to ask, like, "Oh, a monad is a monoid, blah blah blah." Doesn't matter. The big thing to know is that monoids, endofunctors, and monads, they're names of design patterns. No different than if you're in OO world and we talk about builders and factories and singletons. They're just design patterns. They just have weird names. They have different names. Shouldn't say weird. They have different names because monoid, monad, and endofunctor come from mathematics. They come from a branch called category theory. So if you have something that's called a monoid, you know you get certain things for free. Kind of like if you have a singleton, you know, oh, there can only ever be one instance of this ever newed up. I know it's going to have like a .get instance method, right? A monoid says, hey, if you've got this, you've got like an identity value you can use, and you've got some binary operation. I actually wrote a blog post not too long ago about monoids and that design pattern. So if you're interested, Ryan, I can put that in Discord for you. Though, given the smiling face you've put in there, maybe you were just trying to troll me, which I always enjoy. So thank you.
Back snickering.
Oh, love it. Thank you, sir.
Any other questions? Okay. I think we are wrapped. If you do have more questions, feel free to drop them in the Discord. Cameron's going to be hanging around in there and in the Dev Night chat channel. I'm sure he'll be willing to follow up there. And can you share slides and stuff like that in there as well?
If you're in there, I actually already posted a link to everything you need. I'm already have you, sir.
He's on top of it. Excellent. All right. Well, I have a few closing slides that I need to jump through. But Cameron, thank you so much. Let's give him one more big round of applause before I hang up.